Let's now look at a capacitor. Firstly, what is a capacitor? A capacitor is constructed from two parallel conductors, normally two metal plates as shown here. We then insert a non-conductive insulating medium between them. The value of the capacitance depends on the surface area of the conductor and the width of the insulation. As the insulation thickness decreases, the value of the capacitance increases. As the surface area of the conductor increases, so does the capacitance. Let's now see how a capacitor reacts when a DC supply is connected to it. Here we have a DC source with a positive and negative terminal, and a capacitor with two plates with an insulator in the middle. The Q plus and Q minus represent the charge on the capacitor. As the DC current starts to flow, the positive and negative particles pass on to the plates of the capacitor, and the voltage across it grows. Once the plates are fully charged, the flow of current will then stop. The capacitor remains charged and the voltage potential remains across the capacitor terminals. If the battery is then removed and replaced by a load, the capacitor will discharge its stored energy into it. Let's now see how a capacitor reacts to an AC supply. Here we have our capacitor as before, with a Q plus and Q minus representing the charges. The AC source has a live and a neutral. We're now applying a sine wave. As the AC voltage goes through the positive cycle, it charges the capacitor. As the AC voltage goes through the negative cycle, it discharges the capacitor. This charging and discharging cycle by the capacitor disrupts the AC power flow. The value of this disruption is called the capacitive reactance.